All right, hello. My name is Lucas, and I am going to attempt to help you guys understand problem number 16. So when I first look at this problem, obviously, I want to understand what it's asking. So it says, how many integers does x satisfy? And basically what this means is that we are going to try to figure out what numbers, whole numbers, if you plug into this equation, what numbers are going to satisfy it by making x, or the total number here, less than 0, aka negative. So we have to try to plug in numbers to make the equation negative. In doing so, I was kind of just looking at the problem and trying to read it a little bit and realize, okay, so we have these four factors that were given. Obviously there's a dot 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 here, meaning that there's x minus 12, and it just keeps on going. So it's x minus 3, x minus 6, x minus 9, x minus 12, x minus 15, and it goes all the way up until x minus 1392. So the first thing we want to do is figure out how many factors there actually are. And at first when I did that, I was just like, okay, we have total factors. We have 3, x minus 3, we have x minus 6, we have x minus 9, we have x minus 12, 15, 18, you get the point. I did this all the way up till 30, and then I realized, I was like, okay, wait, this right here is 10. So I could do the same thing, and instead of writing them all out, I could do it till 60. And that would just mean that's another 10. And then 90, and that would mean that's another 10. And then I was like, okay, this 10, 10, 10, right? We go from 3 to 90, that being 30 total factors in these 90 numbers, right? So the ratio, I realized, if you have 90 to 30, that's a 3 to 1 ratio. So I thought to myself, and I was like, okay, this pattern is just going to continue. And I realized that this number is probably divisible by 3. So if I just divide the biggest number that we have by 3, I should get the total amount of factors. So you take 1,392, we divide it by 3, just doing basic division. 3 divided by 13 give us 4. We have 12, we have remainder 1 right there. Bring down the 9. 3 divided by 19, we can only do 18, right? And then that's 6. And then we're going to bring down the 1 again. And then 2. 3 divided by 12 is 4. And if we do that math out, get to 0, we have our total answer of 464, right? So that's the total amount of factors. Now that's not obviously the end, that's just the total amount of factors that we have. So now that we figured out how many factors there are, we can actually keep going with this problem, because we needed to know this to know, just for example, if there was only these 3 factors, right? And I plugged in, meaning that I plugged in 0, or not 0 specifically, maybe like 1, right? That would mean you plug in 1, 1, 1. This would be negative, sorry. And this would be negative, and this, right? So what we're gonna get, we have a negative, negative, negative. Negative times a negative is positive. Positive times a negative is a negative. And we want a negative number. The problem is, this is 3, right? 3 is an odd number. So if we have an odd number of factors, that means we're gonna get a negative number, as you can see right here. But since this is a even number, we have 464 factors. That means that if we, plugged in 1, this, 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 and everything after it would be negative, right? So that means it would be negative times negative times negative, and at the end, it would make the number positive, which is not greater than 0, or is not less than 0, I'm sorry. So that means that we need to skip this one, right? So we'll just cross that out, just not literally, but we're not going to use this one to plug in any numbers. No integers that I plug into here are going to satisfy this equation. So we go to the next one, right? And we cannot plug in 3 for this equation. just to clarify that quickly, because 3 minus 3 would be 0, and 0 times every other number, would make it 0, and 0 is not less than 0. So we can automatically know that we can start with 4 or 5, because we can't do 3 or 6, so the two numbers, whole numbers, in between 3 and 6 are 4 and 5. If I plug in 4 and 5, right, that is going to satisfy this equation. And it's going to make this one, instead of being negative, it'll turn it to positive, which then means that we're going to get an odd number of factors that are negative. And making those odd number of factors means that we are going to get a negative number, because then we have this positive. Instead of being another negative, now it's positive. So that means we're going to get a negative number. So basically, that means every other one will be an odd number, because, even and odd. So we know 464, that's how many factors we have total. But we can only use the numbers of half of the factors, because only half of the factors will be odd numbered factors. So we can divide this by 2 to get 232. This is the total number of odd factors that we're going to have. Now, that means that, this is just the total amount of odd factors, so this only works for the odd ones. Now, the last thing we need to do is figure out how many integers go into each odd factor, and I kind of outlined it here when I drew my numbers here. There's 2 each, and just so I can, clarify that and make sure that, I'm not just messing with you. So we have this one here, we're going to skip this one again, because this would make it even. And if we go to x minus 12, right, we would only be able to use 10 and 11, because 9 would, make this 0, and 12 would make this 0. So we can only use 10 and 11. So for each factor, we can only use 2 numbers that would satisfy the equation in making this still negative, but all the ones before it positive. So we have 232 factors that satisfy the equation, right? But there's 2 numbers per factor. So yeah, it's kind of a boring way to end the problem, but basically we're just going to end up multiplying the total number of factors that are odd by 2, getting us right back to where we started at 464. And yes, this is the total number of integers then that does satisfy x. I hope this helped. Once again, my name is Lucas, and yeah, thanks for watching.